Question number 6 from section 2.7 graphing techniques. We want to graph the following function. Y is equal to the quantity x plus 4 squared. Now recall our basic graph of y is equal to x squared is the parabola that has a vertex right at the origin. And then this is a graph of y equals x squared. Now this new equation has been transformed. This plus 4 in the parentheses means that this graph has been shifted to the left 4 units. So this whole parabola has been shifted 1, 2, 3, 4 to the left, and it's a parabola that opens up. And what this looks like in terms of a table of values, we can make a table of values, which is x and y, which is x plus 4 quantity squared. And you want to choose the right point so that you get the U shape of the graph. And I usually pick a point a little bit to the left and a little bit to the right of that vertex. So I would choose the points -5, -4, and -3. When you plug those in to the function y is equal to x plus 4 squared, you're going to add 4, so -5 plus 4 is -1, and -1 squared is +1. Plug in -4 in the parentheses for x. -4 plus 4 is 0, 0 squared is 0, and you plug in -3 for x. -3 plus 4 is a +1, and +1 squared is 1. So these points, -5, +1, -4, 0, and -3, +1 is a point on this new transformed parabola. If we compare that, it looks most like choice B, the parabola that's been shifted to the left 4 units. Number 7, we want to graph the following function, which is y equals the absolute value of x and then a plus 4. So the basic graph of this is the absolute value of x, which is our V graph. This is our graph of y equals absolute value of x. Now the plus 4 means that the whole graph has been shifted up 4 units. So that this point is going up 1, 2, 3, 4, and then the graph is the V shape like this. You can also make a table of values, x and y, which is the absolute value of x plus 4. I would choose this point, a point a little to the left, a little to the right, so -1, 0, and 1. Plug in -1 into the absolute value of x, you get +1 plus 4 is 5. Plug in 0, the absolute value of 0 plus 4 is 4. And plug in 1, absolute value of 1 is 1 plus 4, you get 5. So these points correspond to the graph -1 for x, up 1, 2, 3, 4, 5. That's a point. 0, 4 is a point, and +1, +5 is a point on the absolute value graph. It looks like choice A is the absolute value of x graph that has been shifted up 4 units. Let's choose that and check your answer. Number 8. We want to graph the following function: 3 times the quantity x plus 3 squared plus 4. This is a graph of a parabola that's been transformed in 3 ways. So the plus, I guess first let's look at our basic parabola, which is the graph that has been a parabola that opens up. Okay. Now the plus 3 on the, actually, let me highlight it there. The plus 3 would indicate that the graph has been transformed by moving that basic graph to the left 3 units. the next part, the plus 4, the plus 4 would indicate that the graph has been shifted up 4 units. And then finally, that 3 out in front would indicate that the graph has been transformed by becoming more narrow. And we can also call that a vertical stretch. So we can make a quick sketch of the graph by looking at this vertex and shifting it to the left 1, 2, 3 units, and then moving it up 1, 2, 3, 4 units would be the parabola opens up, but that 3 in front is going to make it a very narrow looking parabola that opens up. We can double check this by plotting a few points, x and g of x, where g of x is 3 times the quantity x plus 3 squared plus 4. And we're going to plug in a few values. Let's plug in, say, -4, -3, and -2. And the reason why I chose those is because this graph has been shifted to the left 3 units. So I want to look at left 3 units plus another one to the left and one to the right. When you plug in those values, -4 plus 3, evaluate that first, is -1. -1 squared is +1. 1 times 3 is 3. And 3 plus 4 is 7. Plug in -3. -3 plus 3 is 0. 0 squared is 0. 0 times 3 is 0. And 0 plus 4 is 4. And then finally plug in -2. -2 plus 3 is 1. 1 squared is 1. 1 times 3 is 3. And 3 plus 4 is 7. So this corresponds to 3 points that are on this graph. Over -4 up 7, -3, 4, and 2 up 7, -2 up 7. So this graph looks most like, I would say it looks most like B. It's a graph that's been shifted to the left 3 units, up 4 units, and it's a vertical stretch. So you can see it's more narrow. Let's choose B and check our answer. Okay, just a couple more in this section. Number 9. This is to graph the following function, which is y is equal to the square root of, under the square root, we have x plus 4. So we have this, our basic square root of x graph. It's a graph that looks like half of a parabola that opens to the right. This is our graph of y equals the absolute value of x. Now what this plus 4 does to the graph is transforms it by shifting the whole graph to the left 4 units. So this graph, where it starts here, is going to be shifted to the left 4 units, and it's going to be that absolute value of x plus 4 graph. The whole thing has been shifted over 4 units. And you can make a table of values. Okay, if you plug in -4 for x, -4 plus 4 is 0. The square root of 0 is 0. Plug in -5. -5 plus 4 is, I'm sorry, -5 plus 4 is -1. It's over here. It actually, you get the square root of a negative number, so this does not exist. That's why the graph is not going over here to the left -5. Should have chosen -3. -3 plus 4 is 1, and the square root of 1 is 1. And let's pick a number like 0. If you plug in 0 for x, then you get 0 plus 4 is 4. The square root of 4 is 2. So we have this graph that has points -4, 0. -5 doesn't exist. The graph does not exist over there. -3 up 1, and then 0 up 2. So that is our new transformed graph. And that one looks most like choice C for me, the graph that has been transformed by shifting to the left 4 units. Okay, now finally the last question here. We want to graph the following function, which is g of x equals the -1/2 times the square root of x. Well, we take our basic square root of x graph and we transform it by putting the negative in front. Oops. Okay, this is y equals square root of x. That's our basic square root of x graph. Now what happens here is this negative part is going to make it flip down, and then the 1/2 is going to make it shrink vertically. So it's going to look something like this. We can sketch a few points. We can say the negative flips it. It flips across the x-axis, and the 1/2 kind of shrinks it vertically, shrink vertically. You can make a table of values, x and g of x, which is that -1/2 absolute value of x. And let's plug in some values, like for example 0. Plug in 0, square root of 0 is 0. 0 times -1/2 is 0. We plug in 1, square root of 1 is 1. We get -1/2. I'm going to plug in 4. Plug in 4 because I want to plug in perfect square, so I get a nice integer value out for the square root. The square root of 4 is 2, and 2 times -1/2 is -1. So this is what a few points on your graph are: 0, 0, 1, -1/2, and 4, -1. Okay, close enough. It is just a sketch, and it looks most like choice D. It is the basic square root graph that has been shrunk vertically, getting closer to the x-axis. And the key to doing these is to be familiar with the basic graphs, and then also being familiar with the transformations, because all of the questions in this section were a basic graph, either y is equal to x squared, y is equal to the absolute value of x, or y is equal to the square root of x. Take one of those basic functions and transform it, and you come up with a new graph.